So here I'll directly write this expression, which is the arithmetic mean of these 52 numbers. And I always like to write it out descriptively up to a51 plus a52 divided by 52 is 1 less than the arithmetic mean of a2 plus a3 all the way to a51 plus, I'm separating those two out, and these are 51 numbers, 1 less. Now a52 is already given to us. That's 100. That's 100. And my interest is in a1. So the piece that's common to both is the sum from a2 to a51. I'll call that S, and I'll come back to that one. Plus 100 over 52. S plus 100, because a52 is 100. 51 minus 1. Now I'm going to multiply both sides by 52 times 51 because I want to get rid of these denominators. So this would become 51a1 plus s plus 100. This will become 52. My s kind of looks like 5, so watch out. And then 52 times 51. This becomes 51a1. So right now I'm just kind of cleaning up things to see how much simplification I can do before I go after what can I do to get the largest possible value. So that becomes just S. That's 100. So 51a1 is S plus 100 minus 52 times 51. I'm going to divide this. Maybe there's a way to get to this result quickly, but this is how so that's where I am. Now you'll notice here, if I want to make a sub 1 as large as possible, I need to make s as large as possible, because the others are just numbers. Right? Plus 100, these don't make a difference. The larger I make that s, and what is s? S is a2 plus a3 to a51. So this sum is what I need to make as large as possible. Note here, a52 is 100, and all of these other terms are less. So the best I can do with a51 is 99, and they're all distinct, and they're integers, which means this is our sequence. a51 is 99, a50 is 98. That's the highest I can make their sum, 97, and all the way to a2. So this is 50 terms. So if this is 99 going backward, would mean common difference is 1, and I'm looking for the 50th term. So 50 minus 1, 49. So that would be 50. So this is kind of the best I can do in terms of the sum of these values. Now I just need to find out what is their sum, meaning the maximum possible value of s. So I just need to add this 50, 51, all the way to 99. And here the average is 50, because it's an arithmetic mean, arithmetic sequence. So this is their average, and how many terms do I have? I have 50 terms. So this is the highest possible sum, which is 149 over 2 times 50. So at this point, I will have to do this multiplication. So that's 3725. That's my maximum possible value for s. Now I can plug it in here to figure out what is the corresponding highest possible value for a sub 1. So plus 100 divided by 51, I get 75 minus 52, which then turns out to be 23, which is answer choice D. So this is a hard question. I'm not sure if I would be able to get this in the exam, because this step of manipulating, that's a little bit of work, and then kind of recognizing how to make that S as high as possible. You have to kind of use that logic. I mean, you can certainly try the answer choices as well. That would be also one strategy. That would also work, although depending on where you start with the answer choices might take more or less time. But yeah, it is a hard question. The answer is 23.